Hello all, I'm Kritika Garg from Web Science and Digital Libraries Research Group at Old Dominion University. I'll be presenting our work on lessons learned from longitudinal sampling of a large web archive. To give you an overview of the presentation, I'll be talking about the strategies and lessons we learned from sampling the archive web and collecting 27.3 million URLs with 3.8 billion archived pages in each of 26 years of Internet Archive's existence from 1996 to 2021. The motivation behind this work was to obtain a sample of the web that could be used to revisit fundamental questions of the web, such as how long does a web page last? The commonly cited answers that we know are 44 days, 75 days, 100 days, all of which are from research that stems back to 1996 or 2003. We curated representative sample using the archived web. We initially set out to create a sample of 25 million URLs with 1 million URLs first archived in each of 25 years of Internet Archive. We sampled 285 million URLs from Internet Archive's ZipNum index file, which includes URLs of embedded resources. We filtered them for web pages, for more specifically valid HTML pages, which brings us down from 285 to 92 million. Then we downsampled further to 27 million by reducing the number of domains with single URL and URLs of overrepresented domains. We sampled 285 million URLs from IA's ZipNum index file that contains every 600th line of the CDX index, which includes URLs of embedded resources such as images, JavaScript, CSS, also robot.txt, HTML, everything. To limit our samples to web pages, we filtered these 285 million URLs to 107 million likely HTML URLs. How we did that is we filtered them based on trailing slash and file name extensions such as .do, .php, .cgi, .htm, .html, etc. Then we collected the very first entry of CDX for all 107 likely HTML pages. This gave us first time the URLs were archived and their MIME type. For example, looking at the first entry of time map of example.com, we can tell that it was first archived in 2002, and we can see that it's a HTML page as its MIME type is text/HTML. So once we had this first CDX entry for all the URLs, we saw how well we performed and predicted the HTML pages based on the extensions. So we got 92 million URLs out of 107 million, which shows that 86.12% URLs were correctly predicted as HTML. And this table shows how well each heuristic performed. Most of them have above 90 accuracy, with .htm being the highest with 98.3% accuracy. We grouped the 92 million URLs with text/HTML MIME types based on the year it was first archived. The graph here shows what we all know, that there's been a significant increase in web and archiving capacity over time. We have larger web now compared to 90s, and IA is doing good job of archiving it. We see increased number of HTML URLs archived over the years. But we have these early years, 1996 to 2000, which has way less than our initial goal of 1 million URL. So one of the challenges is to upsample them. Next, we have too many URLs in the later sample, which needs to be downsampled. Also, I would like to highlight the fact that both 1996 and 2021 has partial data. 1996 has partial data as IA Wayback Machine started in May 1996. 2021 has only 8 months of data, as the index file that we use is from August 2021. The other thing that we learned is how deep links has increased over the years. So we extracted host name from these deep links. For example, this reddit.com/Argentina/comments, this whole deep link, we extracted the host name from it, https reddit.com, and then we saw if it is already present in our data set or not. So we found 20 million such domains which were not already in our data set and added it to our sample. And that helped us upsample the earlier years. As you can see in this graph, the percentage distribution of root versus deep links, the root is marked by red while deep links are marked by blue. We see percentage of deep links archived compared to root URLs has increased over the years. Upsampling allowed us to populate these URLs in early years, which holds more interest for our study compared to the recent URLs. We also noticed in our sample that most of our yearly samples had a long tail of domains, domain with just one URL. For example, in this 2016 sample, 1.7 million domains, which is 79%, have just one single URL. So we get this skewed right distribution here. In this table, you can see the 10 random domains from this long tail. Some of the long tail of URLs features domain likely that are likely not part of most users' experience, such as this 000.cn and zzz7.com. Although we can't be sure for foreign sites such as these blumenkolzeman.de. So for some of the yearly samples with the longer tails, like we saw for 2016, we kept only 10% of the long tail and then discarded the rest. The other challenge that we found was that most of the popular domains such as Twitter, Amazon, Yahoo were overrepresented. For example, in our yearly samples, you can see how there's like large discrepancy between the number of URLs of top domains and the others. And if we add them over the years, for example, if we were to add yahoo.com over the years, like 13.5K, then 11K, and then 11K again, we will have these overrepresented in our sample. We devised this equation for logarithmic scale downsampling to reduce these oversampled domains. The reduced URLs is equal to minimum of n comma k into log n plus c, where n is number of URLs sharing a domain. So for example, we had 1.3 million URLs for github.com, but we don't need 1.3 million URLs for just one domain for github.com. Having a lot of URL for a single domain eventually has diminishing results. It is sufficient to say that we can have a coverage of github.com with a smaller quantity. So 1.3 million URLs for github.com was reduced to 234 URLs. This in this case, 1.3 million is the n, and then we have the output that we got is 234 URLs. So the K and C value was decided based on the yearly samples. Through this technique, while we were able to get downsample github.com, the 3 URLs for peaceinspire.com stays as it is. So we applied this technique to every domain in yearly sample. We adjusted the parameters K and C to get almost 1 million URLs in total for each year. So C ends up being constant value of 1 in our case, and while the K varied for each yearly sample. In the end, we readjusted our goal to sample of 27.3 million URLs while ensuring fairness in the domain representation. So downsampling here largely flattened out the large discrepancy that we had in number of URLs per domain, while we had huge difference in number of URLs before log scale downsampling. Afterwards, you can see there's no longer the case. That there's not much difference in 380 URLs versus 376 URLs, but it got down ranked by 4 spots. So our formula does not strictly maintain the ordering. For example, like yahoo.com, which was in 8th place before, before the downsampling is now ranked 1. The two ranking are highly correlated with a correlation of 99.4%. So even though these tables look different before and after the downsampling, they are very similar. The other takeaway from sampling for us is that dereferencing and downloading content from archive for 27.3 million URLs is expensive. For these 27.3 million URLs, we had to download all the time maps, which took us 22 days and 1.4 TB storage space. And these time maps contain just the metadata about the memento. It's not the actual content. To get the actual content, we would have to download the mementos. These 27.3 million time maps have almost 4 billion mementos in total. If we were to download all of them, it would take us around 172 years. This cost is without any parallelization, but still it's an expensive operation. One thing we understood while looking at the number of mementos is that over time, root URLs tend to collect more mementos than deep links. As you can see in this animation, we have mementos on the y-axis and URIRs on the x-axis. The diagonal here marks the average memento per URIR, and you can see the red dots that are root URLs are mostly above the diagonal, while all the blue dots that are deep links are below the diagonal. We see early years have fewer deep links. For all the yearly sample, deep links are below the diagonal, except for 2021. This is because one of the deep link in 2021 have more than 100 million mementos. Later, years have fewer root URLs. All the root URLs that were discovered in early years have more lots of mementos. And most of these root URLs that were discovered in early years, such as 1996 to 2002, are still linked on the live web and are still being crawled by IA. Some of these URLs are popular domains like bloomsburg.com, facebook.com, ebay.com, etc. Some of the root URLs could also be in this list due to domain drop catching. So domain drop catching gives the appearance that this URL is still alive. We also found that some deep links are not crawled or rarely crawled. For example, this deep link of MSNBC that we found on Memento exists on the live web, even if it's a redirect, but no live web links to it, and it's not indexed by Google. Since it's not indexed or linked, it's not archived, even though we discovered it from a Memento. Another thing to note here is such URLs are not part of our collection because it's not indexed. We also noticed that starting around 2016, most archived URLs no longer correlate with the user experience, but are now service/framework URLs. In 1996, you can see root URLs like Bloomsburg.com, MSN.com, etc. are the most popular, which seems to be part of standard user experience back then. In 2005, the deep link starts to appear in the most popular URLs. We see both sorts of URLs like youtube.com and deep links, unpopular deep links like ameriplanhealth.com/members. In 2009, all the top well archived URLs we see are service or framework URLs such as this captcha of facebook.com, which are not part of the standard user experience. To summarize, we employed various sampling strategies to curate our representative sample. The final sample consisted of 27.3 million time maps, comprising almost 4 million billion mementos spanning from 1996 to 2021. The challenges and lessons we learned along the way are few of them are archive index contain more than HTML pages. We correctly predicted 86% of HTML pages using extension. Web and archiving capacity have significantly increased over time. So we had fewer URLs in the earlier years. Percentage of deep links archived compared to the root URLs has increased over the years. We also saw that our initial sample was dominated by the long tail of domains with only one URL. So we reduced it by 90% and only kept 10% of the tail. The popular domains such as Yahoo, Amazon, Twitter were overrepresented in IA. So we applied domain-based logarithmic scale down sampling, which helped us ensure the fairness in the domain representation. We also saw that computation and storage expense of dereferencing and downloading content from 27.3 million URLs and their 4 billion mementos is expensive. We also saw that root URLs tend to collect more mementos than deep links over time. Most root URLs from early years are still crawled by IA. Also, the popular URLs in IA after 2016 are no longer end user HTML pages, but they include service or framework URLs. Thank you.